In a previous video, we saw an overview and animation of how retrofit classes in the retrofit library can be used to take a JSON stream and create objects of Java classes. In other words, plain old Java objects. In this video, we're going to jump right in and look at a hands-on example and see how we can implement this in an IntelliJ IDEA Spring Boot project. The first thing that we need is a JSON service that's publicly accessible that we can access. I've made a list of JSON services that I've seen in student projects before at this website, jsonservices.com. So if you're looking for something, this might be a nice place to start to look. For example, recipe, you can see some recipes here, some meals and the like. You can see winners of Nobel Prizes. And then we can also see plants, naturally. So several different things that we can look at. This is an example where we're looking at a plant search. So I've pulled up a similar endpoint here where you see the domain is plantplaces.com, and then Perl mobile, and then view plants JSON array.pl. And then we're filtering based on the name oak. I filtered based on oak so it would give us a reasonable set of data back. There are 6,000 plants total in this database, so if I didn't filter by oak, we'd get 6,000 results in return. Now what we're looking at is essentially a scientific definition of a plant. So what can we say about all red maples? What's their fall color? When do they tend to bloom? What does their leaf shape look like? So we're speaking in generalizations about all plants when we're looking at plants. Remember, so far in our application, we've been talking about specimens, which is a specific plant at a specific location. So essentially, we're setting up a one-to-many relationship here. We're finding plant data out on the internet that we're going to integrate that describes our plants. And then we are generating specimens of that plant. And we're saying, I planted a specific red maple at this location in my yard, and I planted it at this date, I watered it, so on and so forth. So plant, the general scientific definition, and specimen is one that we can touch. Since we have an enterprise application or a microservice application, we can have a DAO that represents our plant, and we can have a separate DAO that represents our specimens, and then we can pull this relationship together in our service layer. So that means we'll need a new DAO class for our plant plus an interface, and we'll also need a new DTO type, because remember that DTO is a complex object that floats among layers, and we'll essentially have one that represents the scientific definition of each plant, as we have one that represents each of our specimens thus far. Let's start out by making that DTO, and then we'll make the DAO, and then we'll go back and create the retrofit client instance. For the DTO, we can get a little help from a source online. First of all, let me limit this one down a little bit more, and I'm going to say Asimina, which is a genus that in our case has only one species, so it's just going to return one record, which is just a little easier to visualize. Now what I can do is go to JSON schema to Pojo, and I can paste in that raw JSON, make sure I have JSON checked over here, and then I can choose preview. And you see here it's going to give me a preview of a DTO. Now this is a bit complex for my needs, especially because we know we can use things like Lombok. But it at least gives me a list of properties or attributes it was able to parse out from that DTO. So I'm going to copy these, run back to my editor in the DTO package, and say new Java class, and we'll call this one plant. And go ahead and add to version control. Now if we take a look at specimen, we know that we were able to create a DTO using our Lombok annotations by just describing the attributes, and then Lombok fills in the getters and setters for us. So let me go into this plant, and those attributes are exactly what I pasted from that JSON schema to Pojo website we saw just a moment ago. Now it gave me this JSON property annotation. I'm going to use one, though, that's a bit more specific to our case, which is the serialized name. So we'll just do a find replace, and where we see JSON property, we'll replace that with serialized name. And now we're going to need to more than likely add a Maven dependency. In this one, it suggests to us serialized name from com.google.json.annotations, version 2.85, and sure enough, that's what I want. So I'm going to go ahead and choose add. It'll take just a moment to sync, but nonetheless, we can go to our POM XML, and we see that our IDE has been kind enough to add this dependency for us. So we'll give it a moment to sync. As a matter of fact, here's a little icon we can hit to kind of give it a bit of a nudge. And you notice that as soon as it syncs and I give it a bit of a nudge, it gives us a new hint here, which is import class. So we'll go ahead and say import, and now our red lines are gone, and at the moment our DTO looks good. Now that we have this DTO type, we can use it as a parameter type and as a return type just the same. So I'm going to go to my DAO and I'm going to create a new Java class. Actually, we're going to make this an interface. Interface is nice because remember, an interface is just a list of methods. And what we can do is make an interface that Retrofit understands, where we make a method, we annotate it with an endpoint, and we say this is what we want you to call, and then we say this is what we want you to return, and Retrofit will figure out all the rest. So let's call this one plant retrofit. Let's call it iPlant retrofit DAO. So we're saying this is a DAO that is specific to retrofit, and it's simply going to be an interface, which means we define the contract and retrofit figures out the rest for us. So iPlant retrofit DAO. I'm going to create this method one piece at a time because there are a lot of things that are going on in it. So I know I'm going to change some of this. We'll start by simply saying void, and that's one thing that's going to change. Get plants. And we're going to have some more things that change in here, of course. Terminate with a semicolon. Here's the important first part. We need to say @get, which is an annotation that says, I want to post a GET request to this endpoint. Now, when we think endpoint, we're considering not the domain here, but everything that follows the domain. So let's go ahead and grab that. And then in quotes, we'll paste that endpoint. Now, okay, a couple things to do. First of all, we have a red line, so let's Alt-Enter. And you see, it doesn't really know what to do with this one. It has create annotation or add Maven dependency. Let's go ahead and add Maven dependency. A trick with this one is that get is an ambiguous name that's used in many different places. So when we search for a class, it could be just about anything. Luckily, ours comes up as the first option, which is retrofit2.http and retrofit230. So I go ahead and choose add. And once again, we give Maven a moment to sync. Now with the moment to sync, we hold Alt-Enter and we see that it is able to implement that get automatically. Okay, couple things we need to think about here. First of all, the endpoint typically won't include a query parameter. You see, the query parameter I'm highlighting here is something that we use to filter down those results. But instead of putting it directly in the endpoint, if we did that, we'd always have that filter on. We can make that a parameter instead. So take off the question mark. Now look at the name common name, and let's copy that. Let's take off everything after the equals because that's what could change anytime this method is called. Now let's go to get all plants and let's add a new annotation @query and then give that open and close parentheses and open and close quote and then paste. And let's go ahead and import. There we go. Once again, that's a retrofit class because we added that to our POM earlier. You can see that the import finds itself up here. So now we have an annotation @query combined name. Now let's put a parameter variable after this, string combined name. What that means is that this method can be invoked with a string parameter. And if it is invoked with a string parameter, Retrofit behind the scenes is going to take this value, add it to the endpoint with a question mark, and then whatever value was passed in will follow that name and an equal sign so that we can use that to filter down. Not every endpoint will have this, but if you do have an endpoint that accepts filter parameters like this is how you can handle it. Okay, one more thing, we need to think about our void type here, and we need to think about what we're getting back from this method. You see it's called get plants, and we can tell a lot from that. Get indicates a read operation. Plant indicates that we're getting a plant type back, and plant with an S indicates we're getting multiple plants back. So, well, we have plant, we just made that in our DTO. So we can change this return type to list plant get plants. Just a few more things that we need to do now. Let's go ahead and import that and import list, and there we go. We need to create a retrofit client instance that will essentially engage our retrofit. And then we also need to make a DAO that will reference this iPlant DAO. It'll be easiest if we make the retrofit client instance first. Sometimes I put that out at the root package, but to me, really, it's kind of a DAO thing because We're going to an endpoint, we're getting data, we're parsing it. So I'm going to go ahead and drop it in the DAO class. So we'll say new Java class, and we'll call this one Retrofit Client Instance. And there we go, and add to version control. This is going to be a singleton design pattern where we have a static method that returns to us an instance of retrofit. So let's start by defining that method. Public static. Now remember static, that means we don't have to create an object to call this method. Retrofit is our return type, and that's the class that embodies all of that retrofit logic we brought in through our POM. And get retrofit instance. Open and close paren, and you see it says, oh, I know you need to import this retrofit thing, so we'll go ahead and do that. The advantage of the singleton design pattern is that it is very memory efficient. We declare an object only once, and anytime there's a request for that object, we simply return the same object without creating a new object. The way we'll often do this is create a private, static, member variable of this class. And that is essentially the variable that's holding this object that gets returned when requested. So private static retrofit, and then inside of our method, we'll simply see if it's been instantiated before. So if retrofit equal null, that means it's not been instantiated and we need to create it. We'll say retrofit equals new retrofit2 retrofit.builder. And then this is the builder pattern. So, don't need parentheses on that. This is the builder pattern, so what we can do is simply chain together a series of options we want to add here. So we'll say base URL, and then we'll give this a constant that we'll define in a moment called base URL. So that's going to be red because we haven't defined it yet. And then we'll say add converter factory, JSON converter factory dot create, and then build. And terminate with a semicolon, and then finally, after our if test, but still within the method, we simply return retrofit. Because you see, by the time we've gotten to line 16, retrofit has been populated. Either it already was populated and this if test did not execute, or it was null and we need to go in and we need to go through all the logic inside the if test. Either way, by the time we end up on line 16, it's all been done. So we have a couple more things we need to do. One is define a base URL. Base URL is everything except for that endpoint that we looked at earlier. So in other words, if we take a look at our browser again, and we know we had the endpoint here, base URL is everything I didn't highlight, essentially this over here. Private static string base URL equals https://www.plantplaces.com, end quotes, and then terminate with a semicolon. Okay, that takes care of that. Now our JSON converter factory, let's see what we have there. Not giving me a whole lot of good options here. So this is a Maven dependency, but it looks like it doesn't know which one. So we might just have to add this one manually. I'll navigate to my POM XML. And since the IDE didn't have a suggestion, I probably could have searched a bit through there, but I did do a bit of research off the top, and I found that this converter JSON is needed. So I pasted that in. Of course, I'll push this up on GitHub so you'll have access to it as well. And now we come back, and you see this time it recognizes the JSON converter, and so there we go, it's able to import it. Okay, great. All we have left then is the concept of the DAO that's going to put everything together. So let me go ahead and make a new, we'll start off with an interface. We'll say iPlant DAO, list plant, fetch plants, string combined name. Just like before, we know that combined name can be a parameter that's passed in to help filter down our list of plants. Go ahead and import both. There we go. Now let's make a concrete class that implements this plant DAO. And add. Implements iPlant DAO. Implement our method. And there we go. So now we simply need to make this go over and call the plant retrofit DAO. And also in doing that, it's going to need to take use of the retrofit client instance. So let's put that in. We'll start by getting an instance of retrofit. So we'll say retrofit client instance dot get retrofit instance. Now take a look at that. Do you see how I just put in the class name retrofit client instance without creating an object? And it gives me this get retrofit instance method that we made earlier. Well, the reason is that method, remember, is static, so we don't need to create an object first before we use it. Okay, terminate with a semicolon, and we'll save this. Control-Alt-V is a nice shortcut in IntelliJ. If you put that on a method call, it will look at the return type of that method call, and it will automatically make an assignment statement that assigns that to a variable, which you see is what we did here. So now we'll say retrofit instance, and then dot create. And for the create, we pass in that interface that we created earlier, the iPlant retrofit DAO. It's simply going to create an object that implements this interface. Now we need to say .class because we're passing in that type. So this will return to us, well, I'll tell you what, let's see if IntelliJ can figure it out. It did, nice. So it returns to us the plant retrofit DAO. I'm just going to call it, plant retrofit DAO like so. And then from plant retrofit DAO, what can we call? Well, guess what? We can call that get plants method, and we can pass in combined name. But we have to do a few more steps because retrofit is going to put this into an asynchronous call for us. So what we need to do is say call, which is a return type, and then a generic identifier for call, which represents what the getAllPlants method returns. Let's remember what that returns. GetAllPlants returns a list of plants. So getting a little bit closer. So we put call, and then list plant, and then we'll say all plants equals plant retrofit DAO.getAllPlants, as you see here. It looks like I'm missing a square bracket, so there we go, or an angle bracket, so we fixed that. And now it says I don't know who call is, so we go ahead and import that. Now it tells me, wait a minute though, that doesn't exactly match the getAllPlants method from our plant retrofit DAO, because that's actually returning a list of plants. But you're right, we need to wrap that in a call. So let's make these two types the same. And remember again, a call is simply a way that retrofit allows us to do an asynchronous call. In other words, we make a call and hopefully we hear success back. So, okay, we've wrapped that up. Now we'll say all plants dot execute. That's going to start our call. So terminate with the semicolon. It doesn't like it has an exception here, so we're going to need to go ahead and add an exception to the method signature. Probably a good idea to do that, and let's go ahead and take their suggestion here and add it to the interface signature as well, so that it's consistent. Now we have all plants execute, and what's that going to return? Remember Control-Alt-V, and it's going to return a response, which is a list of plants. So for that, we'll simply call it, execute's fine, and then we'll say execute.body. And execute body finally is going to return our list of plants. So once again, Control-Alt-V, and we'll say plants. And now we finally have the plants that have been received from the JSON marshaled into our plant DTO, and we're ready to return those plants. So we'll say, whoops, return plants, and this method is essentially complete. We need to do a bit more wiring so we can test it out. So let's go up to our service layer. And in the iSpecimen service, we'll make a new collection, or a new method rather. We'll say list plant fetch plants string combined name. Import our class just like so. Now that's going to tell us our specimen service stub is going to need to change as well, and we're probably about the point where we can make this into an actual implementation class. But let's go ahead and implement methods just like so. Okay. Fetch plants return null. Okay, well, we need access to our plant DAO, and you notice here we have a service that is calling into now two different DAOs, which is what a service does. A lot of times it's aggregating together these different calls to more finite DAOs. So let's go ahead and say private iPlantDAO, plant DAO, and we'll need to add an @AutoWired annotation on top of that, which means we're also going to need probably repository annotation on our actual concrete class. So let's go ahead and say @repository here. So that's essentially the matching side to our component annotation. Good, so red line's gone away, and now in our new fetchPlants method, we can say plant DAO.fetchPlants, and simply pass that combined name all the way through. Now that's probably going to tell us about an exception, so let's go ahead and add exception to method signature, and let's add it to the interface as well. There we go. Okay, now to our controller, we can make a new plants endpoint. Actually, looks like we already have a plants endpoint, so that works for us. As a matter of fact, we already have our search term in that plants endpoint. Specimen service.fetchPlants, and pass in the search term that we have here. We know that's going to throw an exception, so let's go ahead and surround with try catch. We'll do it the easy way right now. We'll simply say if everything is good, return new response entity. If something goes wrong, let's change that from an OK to something else like an internal server error. That'll be fine. I'll borrow a bit of logic from my fetch by specimen ID here to make that response entity a bit more intelligent on our plants endpoint. So we'll paste like so, and down here we'll say, well, we need to save the plants, don't we? So let's go up here, Control-Alt-V, save that in our list of plants, and let's see, for response entity, the order is what we want to pass back, and we're saying that's JSON, any headers, and then the HTTP status. So back down to our plants endpoint, we want to pass back a list of plants, and then we have our headers, which we've defined right here as application JSON, so we'll say headers, and then status OK if everything went OK. If something went wrong, we respond back with our internal server error. One more thing I remember that I need to do is add the Lombok annotations to our plant class. I went through and added all of the attributes, but not the Lombok annotations. So let's go ahead, public at data, Alt-Enter, import class, and there we go. Let's try a full integration test now. You see that I've started the application, I've set a breakpoint in our endpoint, and I went ahead, I've gone to the endpoint plants, and I'm going to add question mark and then search term equals oak. Now, if all looks well, we will essentially see the same data here that we saw when we went to the plant places endpoint directly. But the advantage is that we're bringing this in through our application so we can do any kind of filtering or massaging of this data as we need, or we can use it to implement the one-to-many relationship between plants and specimens that I spoke about earlier. So, search term is oak, and as soon as I hit that, IntelliJ lights up in orange, so we'll take a look at this. First of all, this is our endpoint, and so if I take a look at search term, you see that it is oak. Note that we're in the controller, which is the C level of our model view controller architecture. So F7 means step into a method, F8 means execute the method silently and move to the next line. Right now I'm in the controller, but the method that's about to execute is fetch plants on specimen service, and I want to see what happens in there. So I choose F7, and I see that sure enough that takes me to the service stub, which is going to reach down to the DAO. So I choose F7 in there, and this comes to that plant DAO that I created earlier, where we create the retrofit instance, and then we put together a call, and then we wait for a response, and then we get the body of that response. So I'm actually going to hit F8 fairly quickly through here so that you can see there's a little network lag when we get down here to line 19 or 20. But if all works well, we should get back a list of about 63 oaks. So F8, 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 you see a little pause there, F8, and what do we have back? We have 63 plants. I expand to see this, and we see that these are all plants that contain the word oak. Here's Korean oak. We can go down and we see bur oak. Every one of these is an oak tree, so sure enough, it matches the search parameters that we put in. So let's go ahead and choose F9 and then take a look at our look and feel on our web page. And sure enough, you see here local on our local Spring Boot application, we now have all of these oak plants just like we saw on Plant Places. So integration is a really good idea because it allows us to add value with our application by taking data from different sources and putting them together and adding some intelligence to them. Being able to parse JSON is central to that. So I hope this video has been helpful, and I look forward to reading your comments. Thank you.